Now in circle theorems, I missed to tell you about this, about the inscribed quadrilateral. A quadrilateral that is drawn within a circle is called as a cyclic quadrilateral. So all the corners should be on the circle. Now if I have another circle, I draw a quadrilateral inside like this. Is it a cyclic quadrilateral? This portion is hanging within the circle. It's not touching it. So it's not a cyclic quadrilateral. CYCLIC. Okay. This is the name of this quadrilateral. Now, if you draw a small circle like this, or if I draw a big circle and a quadrilateral inside, and I measure these two sides, opposite angles of a quadrilateral, I see that the sum is always 180. If this is 100, this is 80. If this is 20, this is 180 minus 20, that is 160. Okay, and this one, if this is 100, this is 80. Like this, the opposite angles, the sum will always be 180. You read again the theorem paper that I gave you with all the theorems in it. Okay, just go through the first 4 theorems. And one of them is this: the sum of the opposite angles of a cyclic quadrilateral is always 180 degree. Now in your textbook, you will see the questions wherein it's given as x and this is x plus 2. Now how do you solve for this? You already know that the sum is 180. So x plus 2 is equal to 180 degree. X and x you can add together, 2x plus 2 is equal to 180. Now here 2x is equal to, your plus 2 you bring it to the right side. There are 2 ways you can do. Either you subtract 2 on both sides, you remember, this might be the way you have learned in your smaller classes, or you can learn a new way wherein whatever is there on the left side, here it's plus and minus. Okay, earlier you remember I told you to bring all the multiplication terms like this. When you have terms in the numerator or denominator which are multiplication terms, you bring it to the denominator, that's it. Here you can't bring it to the denominator, it's plus 2. When you bring it to the right side, it becomes minus 2. So 2x is equal to 180 minus 2. It's the same, okay? When you subtract 2 on both sides, the same answer I'm getting here. So 2x is equal to 178, and then here 2 into x, right? So I want the x alone. From the left side, I bring to the right side. So it's 178 divided by 2. It's in the numerator, the multiplication term. I bring it to the right side, it becomes division. Find the answer for that. Suppose your answer is, how much is it? 2 8s are 16. 89. Suppose your answer is 89 degree. So x is 89. This will be 89 plus 2, 91. Okay. So 89 plus 91 will give you 180 degree also. So this is how you solve for the opposite angles in a quadrilateral. Okay, so I had missed to put this in the previous video, and I'll just show you. See, this is minor arc. Small one is minor arc. It's the major arc. The measure of minor arc is the same as the central angle. Now the measure of this arc in degree is the same as this angle. Now here you have a semicircle, so this angle will be 180 degree. Clear? So the measure of this arc in degree, you can say it is 180 degree, the same as the central angle. What else? Here, look at this question. You have BAC 70 degree. It's an inscribed angle. So what is the measure of the arc BC? It's 140 degree. Why? Because inscribed angle is 70 degree. If you draw a central angle here, this will be double 140 degree, which is the same as the arc measure. Clear? I have a quadrilateral here. The opposite angle sum will be 180 degree. What else? Here you have the y and x terms. So here 5y plus 3 plus 15y plus 17 is 180 degree, the opposite angles. Okay, opposite means if this is P, not the angles on the same line, okay, the other one. Because some of you even have doubt which is opposite. Not on the same line, the opposite side. So these, when you add, it should be 180 degree. So you have questions in the textbook wherein x and y are given. So revise all this. There will be question from this too for the quiz to find x and y. Then the last one was this, wherein you have to find the arc measure and the arc length. Not the arc measure, the length of the arc. Suppose my minute hand is like this, 12 to 12:30. This angle is 180. I can find the length of this arc using the formula 180 over 360 times 2 pi r. You need to know the radius. The radius will be the length of this needle which is given in the question. Okay. And you also should know for a clock, every 5 minutes means 5 degree, right? Sorry, 30 degree. Every 5 minutes means the central angle is 30 degree. So this is 30 into 30 plus 30 plus 30, like this. If you have 6 times, it will be 180 degree. Clear? Why do you need to know it's 30 degree? Suppose I draw a clock and I tell you when the minute hand moves from 12 o'clock to 12:05. Okay, this is arc length I want to find out. So how do you find? Theta, which is, now you know, every 5 minutes is just 30 degrees. So 30 over 360 times 2 pi. I'll give you in the question, the minute hand is 10 inches. So you put 10 and your answer is arc length means it's a length, right? What you find with a scale, with a ruler. But since you can't keep a ruler on a curve, you take a string, measure the length, and then you keep it on the ruler. It's the same answer that you get when you find it using this formula. Clear? So go through all the questions in the textbook too. This is 16.2, arc length and radian measure. And then we finished almost all the questions from 15 point, which was this 15.1. okay, it's about the inscribed angle and the central angle. And then 15.2 I guess is about the inscribed quadrilateral. Okay, so these are all the theorems that we learned in circle theorem. There are other theorems also related to the circle, but learn this much for the upcoming quiz and for the unit test. Thank you. Bye.